exercise 44, we come to some few examples and the problems on Simpson 3 by 8 rule. We already derived in the previous slide in the Simpson 3 by 8 formulas. Now we derive some 3 by 8 rule and discuss a few problems. See, Simpson 3 by 8 rules. See, in the Newton forward interpolation formula, if we take this difference, some formula is x equal to x naught plus nh. So we find the p is x minus x naught by h. So differentiation we get dp rdh. We already familiar in the previous slide. So then substituting, so h of delta y naught plus y naught plus p into delta y naught plus p into p minus 1 by 2 factorial del square y naught plus p into p minus 1 p minus 2 by 3 factorial del q y naught plus etc. So again I'm simplifying all this term. Give some suitable substitutions. Put a deep n equal to 3 in the form. So put n equal to 3 in the generally quadrature formula. Now Newton Cotes formula gives 3. Then neglecting all a difference above the third higher order degrees. So that is integral from x naught to x naught plus th f of x dx equal to h of 3y naught plus 9 by 2 delta y naught plus 1 by 2 9 minus 9 by 2 del square y naught plus 81 by 4 minus 27 plus 9 del q y naught by 6. So that is h equal to h of 3y naught plus 9 by 2 delta y naught should be equal to y1 minus y naught plus 9 by 2. So again I'm simplifying del square y naught. We already know in the previous slide, simplification of del square y naught is y2 minus 2y1 plus y naught plus 3 by 8. So again at simplification of this term should be equal to y3 minus 3y2 plus 3y1 plus y naught. Again I'm totally simplifying. So this should be equal to 3h by 8 y naught plus 3y1 plus 3y2 plus y3, the first interval. Similarly, if we change the interval, so if we change this, the consecutive difference should be equal to x naught plus 3h to x naught plus 6h f of x. The length should be 3. So the width, simply say the width should be 3. So integral of x naught plus 3h to x naught plus 6h f of x dx will be equal to 3h by 8 y3 plus 3 y4 plus 3 y5 plus y6, and integral of x naught plus 6h to x naught plus 9h f of x dx equal to 3h by 8 y6 plus 3 y7 plus 3 y8 plus y9 etc. We come to the integral of x naught plus n minus 3h of x naught plus nh f of x dx equal to 3h by 8 of yn minus 3 plus 3yn minus 2 plus 3yn minus 1 plus yn. So adding this term, all the terms, so integral from x naught to x naught plus nh f of x dx equal to 3h by 8. So you see only one term appear, y naught plus yn, the first term and the last term, only first. So y naught plus yn plus 3 times of yn, so 3 times of y1 plus y2 plus y4 plus y5 etc. plus 2 times of or multiple of 3 form. So plus 2 times of y3 plus y2, y6 plus y9 plus y12 etc. yn minus c. That is integral of x naught to x naught plus nh f of x dx equal to 3h by 8 of y naught plus yn plus 3 times of y1 plus y2 plus y4 plus y5 except 3, 6, 9. So y2 plus y4 plus y5 plus etc. yn minus 1 plus 2 times of y3 plus y6 plus y9 plus y12 etc. yn minus c. This is the formula is known as Simpson 3 by 8 rule, which is the applicable only when the multiple of 3. Now we come to the some few examples regarding in the Simpson 3 by 8 rule. So evaluate integral from 0 to 6 dx divided by 1 plus x square by using Simpson 3 by 8 rule. See, See, given problem, so already discussed in the previous slides by method of trapezoidal rule, 1 by third rule. So in the same way we are discussed in the form of 3 by 8th rule. Divide this interval 0 to 6 into 6 equal part. Each width should be is 1, means h is 1. The values, so f of x equal to 1 by 1 plus x square is given below. So x is, so it should be equal to 0, 1, 2, 3, 4, 5, 6. So corresponding value should be f of x is 1. If 1.5, the corresponding values of f of x is 0.5. If x is 2, the corresponding values of f of x is 0.2. If x is 3, corresponding values of f of x is 0.1. If x is 4, corresponding values of f of x is 0.0588. If x is 5, the corresponding values of f of x is 0.0385. If x is 6, the corresponding values of f of x is 0.027. So I call this first y0, y1, y2, y3, y4, y5, y6. So I come to the Simpson 3 by 8th rule. The formulas: integral 1 from 0 to 6 dx by 1 plus x square. So substituting the formula 3h by 8 of y0 plus y6. So y0 plus y6 plus 3 times of y1 plus y2 plus y4 plus y5 plus 2 times of y3. So in the sixth term, only multiple of 3 is only 3. There is no 6. So first and last term. So this is the formula. So 3h by 8 in this regarding this interval, 3h by 8 y0 plus y6 plus 3 times of y1 plus y2 plus y4 plus y5 plus 2 times of y3. So that is 3 by 8. If h is 1, see the interval differences is 1. So h is 1. So suddenly 3 by 8 of y0 is 1 plus y's last term y6 is 0.027. So 1 plus 0.027 plus 3 times of y1 is 0.5 plus y2 is 0.2 plus y4 is 0.0588 plus y5 is 0.0385. So substitute plus 2 times of y3 summative. So 2 times of 0.1. So this is y3. So substituting the whole the value and evaluated, we get integral of 0 to 6 dx divided by 1 plus x square is 1.3571. So one more example, we take this same, evaluate integral 1 from 0 to 1 dx by 1 plus x using Simpson 3 by 8th rule. So here the h is not given the interval. So yeah, h is simple. So we take this interval should be equal, dividing 6 part means 0 to 1 is given, divide 6, that we x, if we take x should be 0, 1 by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6 and 6 by 6. Divide this intervals in 6 equal part, we get h should be equal to 1 by 6. Let y equal to f of x, suddenly we get 1 by 1 plus x. The value of f of x for the point of the subdivisions are, so x, if x is 0, the corresponding values of f of x is 1. If x is 1 by 6, the corresponding values of f of x is 0.8571. If x is 2 by 6, the corresponding values of f of x is 0.75. If x is 3 by 6, the corresponding values of f of x is 0.6667. If x is 4 by 6, the corresponding values of y is 0.6. If x is 5 by 6, the corresponding values of f of x is 0.5455. If x is 1, the corresponding values of f of x is 0.5. So this is I called y0, y1, y2, y3, y4, y5, y6. So I have used the formula. So what is Simpson 3 by 8th rule say? Integral 1 from 0 to 1 dx divided by 1 plus x, 3h divided by 8. So y0 plus y6 plus 3 times of y1 plus y2 plus y4 plus y5 plus 2 times of y3. Now substituting, your h interval should be 1 by 6. See? So 1 by 6. So 3 divided by 8 into 1 by 6. Suddenly we simplifying, we get 1 by 16 of y0 should be 1 plus y6 should be 0.5. So 1 plus 0.5 plus 3 times of y1 is 0.8571 plus y2 is 0.75 plus y3 is 0.66. If y3 is this, if y4 is 0.6 plus y5 is 0.5455 plus 2 times of y3. So 2 times of y3 is 0.667. So simplifying, we get the values 0.6932. So therefore, integral of 0 to 1 dx by 1 plus x is in the 3 by 8th rule, the value should be equal to 0.6932. So if we come to the 1 marks problems, say, so evaluate integral from 0 to 3 dx by 1 plus x whole square by Simpson 3 by 8th rule. Since the number of steps is known, if you take the easiest way, so 0 to 3 is there, the take interval should be 1, 0 to 1, 1 to 2, 2 to 3. Since the number of steps to be taken in not mentioned explicitly is not given, so let us take n should equal to 3. By apply the Simpson 3 by 8th rule, the length of each step should be equal to 3 minus 0 divided by 3. So x naught minus p divided by 3 is, so if we take length should be equal to 3, width should be equal to 1. This is form. So x should be equal to 1, 2, 3, 0. If we take 0, 1, 2, 3. So if x is 0, the corresponding values of f of x should be 1. If x is 1, the corresponding value should be 1 by 4, we get. If x equal to, corresponding value should be equal to 1 by 9. X is 3, corresponding value should be 1 by 60. So you are putting values should be x equal to that. X is 1 by 1 plus x whole square. 1 plus x whole square, not for x square. See, put x equal to 1, 1 by 1 plus 1 whole square should be 1 by 2 whole square. So suddenly 1 by 4. 1 by, if you put x equal to 1 by 1 plus 2 whole square, so suddenly 1 by 3 whole square is 9. Suddenly if x equal to 3, 1 by 1 plus 3, so 1 plus 4. So 1 divided by 4 whole square, suddenly 1 by 16. So we have integral from x naught to x naught plus nh f of x dx is 3h by 8 first and last term, y naught plus y3 plus 3 times of y1 plus y2. So substituting integral from 0 to 3, 1 by 1 plus x whole square dx is 3 by 8 of first term is y naught should be 1, last term y3 should be 1 by 16. So 1 plus 1 by 16 plus 3 times of y1 plus y2. So 3 times of 1 by 4 plus 1 by 9. Suddenly we get, we are simplifying, we get 0.8047. Therefore, integral from 0 to 3 dx divided by 1 plus x whole square is equal to 0.8047 by using Simpson 3 by 8th rule. So this is the way, in the way of calculating in the simple formula. We come to the analysis where, suppose for integrating in the manually means mandatory. So we know the method. So integral from 0 to 3, 1 by 1 plus x whole square dx. So what is integral of 1 by x square? Same form, minus 1 by x. Similarly, integral of this should be equal to minus 1 by 1 plus x. So evaluating 0 to 3, the upper values minus lower value minus, so 1 by, if you replace x is 3, so minus 1 by 1 plus 3. So suddenly 1 by 4. Minus of minus plus we get. Replace x is 0. Suddenly 1. So minus 1 by 4 plus 1. So we get 3 by 4. What is a 3 by 4 value? 0.75. So approximately we get. So 0.75, 0.80. So this is the way we are getting approximately. We come to the one more example. So using a Simpson 3 by 8th rule, obtain approximately values of integral from 0 to 0.3 2x minus x square whole to the power of 1 by 2. I simply say square root of 2x minus x square. So here the values y should be equal to 2x minus x square whole raised to 1 by 2. Or h is take a this difference 0 to 0.3. So take number of difference should be equal to, if you take 6 interval, 7 interval, 8 interval. So if you take means it's not two interval is not less interval. If we take minimum should be equal to 4 or 6 form. So take in difference in approximately. So if you take h should be a 0.05 form, suddenly number of terms should be appear 6. So it's not maximum, it's not minimum. So n should be equal to 4, 6, 8 form. So take n should be a 6 form. Suddenly h divided should be 0.05. So if x is 0, the corresponding values of f of x should be 0. If x is 0.05, the corresponding values should be equal to 0.3122. If x equal to 0.1, the corresponding value should be equal to 0.4359. If x equal to 0.15, the corresponding values of f of x is 0.5268. If x equal to 0.20, if corresponding values of f of x is 0.600. If x equal to 0.25, the corresponding values will be 0.6614. If x equal to 0.3, corresponding values will be equal to 0.7441. If you take a scientific calculator, substituting give this x interval. See, this is easy way. So this is given interval. If you take the number of sub intervals should be equal to maybe 4, maybe 6, maybe 8 form. So if you take, suppose you want to do a sub interval should be, you want to maybe 4 10. So any if you take this also should be 0.23 form, 0.03 form, 0.02 form, 0.04 form, like that it should be. So we get number of terms should be like that. So if you take h should be equal to 0.005 term, the number of terms should be equal to 6, like that. So the corresponding y, if you take a scientific calculator, use this. Instead of y should be equal to square root of 2x minus x square, we can write. So by using the Simpson 3/8 rule, use the formula. So we get y0, we get y1, we get y2, y3, y4, y5, y6. So integral from 0 to 0.3, 2x minus x square whole raised to 1/2 dx. So what's the 3/8 rule? 3h by 8 y0 plus y6 plus 3 times of y1 plus y2 plus y4 plus y5 plus 2 times of odd multiple of 3. So 2 times of y3. That is, if a 3, what's the h interval should be equal to 3 times of 0.05 divided by 8. So first y0 should be 0, y6 is 0.7141. So 0.7141 plus 3 times of y1 is 0.3122 plus y2 is 0.4359 plus y4 is 0.660. So y5 is again substitute plus 2 times of y3 is 0.5268. So substituting, so value should be 0.15 by 8 of 0.7141 plus 6.0825 plus 1.0536. So substituting, we get value should be equal to 0.14617. This is the way evaluating the integral from 0 to. So it's not given the interval. We divide. We take this. So in the generally in the subinterval form, the interval should be a number of terms should be either 6, 4, 6, 8, like that. So should be we get the h value, approximately h value should be